Hello everyone. For anyone who's this is their first video, if you're getting ahead of your classes, uh, good for you. And this might be your very first video for BIT 1400. Now, I'm hoping to have synchronous videos or at least synchronous meetings with you guys throughout the term, just to make sure that we can catch up and you can ask any questions that you have. But since many of the videos that we have do not need to be synchronous, they're going over the same material that I've covered before in previous terms. I decided to record all of these and keep them asynchronously. You can get them anytime that you want. Heck, I'm going to try and make sure that you can download the videos if you want. The idea here is it's not going to be as ideal as a face-to-face conversation where we can dynamically make questions, we can dynamically answer questions, or I can dynamically answer questions. But I'm still going to be trying my best to make it as interesting as possible. Hopefully, relatively short videos that you can pause, fast forward, whatever the case is. I have a couple comments about that, but let's get going about what BIT 1400 actually is. In fact, one of the big things I like to point out is that little hokey pokey video up there from XKCD is an example of an algorithm and one of the major things that we're going to be focusing on in this course. I'm saying this because although we're learning C++, this course is how to break down problems and how it's an introduction to programming, how to think through a problem and programmatically solve problems. So whether it's in C++ or Python or C or Java or whatever the case is, it should be approximately the same. It is how you think through a problem, and that skill set is applicable to pretty much anything else you do later on. So why is this important? Well, first of all, there's lots of software development jobs. Even if you're in the net program and you don't want to do anything with network technology, anything IT related, you can still get hired as a programmer. There's lots of programmers that are, physicists that go into programming. Uh, and even if you don't use it as a programmer day in, day out, it is still extremely useful where you get to apply programming. If you're throwing up a script, you're using Python, you're making a script, and you are simplifying your job. It comes in handy in a wide variety of ways. It also, if you have to work with other software developers, whether they're programmers on a team and you're a multimedia designer, but that's not you guys, but for the for BMPD and for IMD programs, that would be the case. For you guys, just being able to talk to software developers is important. Think how they think. You can also break down problems logically and algorithmically, which is just useful in general. How do you troubleshoot? Uh, and so this is a very general skill set. They show up everywhere. And if you don't know why I'm bringing up a subject, please ask when we do synchronous or post on Piazza. These things come up, but I want you to know why they're important to you. Because foundationally, this is a foundational course. That's why it's so hard, actually. But what the reason has to be we have to test you or push you so much is because it's so applicable to everything else in the degree program. The common complaint from other instructors has been in the past where people get through bit 1400, get through bit 2400, and then they get stuck at about third year. And we don't want that to happen anymore. We need to make sure that you're up to speed so that we can, because all of this is going to be cumulative. So, oh, and I should be doing full screen, so sorry about that. Let's let's quickly full screen this thing if I can. My programming. So we did that. Yay. So who am I? I'm actually a visualization and an HCI person, so I don't do IT directly. I got my PhD at the University of Victoria looking at visualization. I teach a phys class here. My master's degree is from UBC looking at human-computer interaction. I was a kids game developer for 2 years. I worked at CD Depco, which is a computational fluid dynamics company. So they have entire rooms full of computers for the server side of any simulation that you're running. You spend like days, if not weeks, setting up one of these physics simulations. You throw it off to a cluster of computers, and they'll spend 2 weeks crunching the numbers to give you the simulation, so you can figure out how the air flows around an airplane wing, or you might be looking at how heat dissipates from a battery. All very hardware related, but it's and very mathy. But I was one of the front-end designers for that. I also worked at Google Cambridge, where I worked at Newsstand. If you've ever used the Google News app, sorry. I used I was teaching at Northeastern University until last September, so this is starting my second year, and I've already had a pandemic. Second year at Carleton, but I was teaching for about almost 5 years at Northeastern, and I'm a Newfoundlander, which really doesn't make any difference at all, other than if you're going to tell a Newfie joke, make sure it's a good one. I love a good Newfie joke, just don't make them dumb. You can come up with better ones. All right, so normally I'd poll the class, what have you heard about the class? What do you know about me? What do you know about the workload of this class? Since I'm obviously not going to be hearing you give me answers, and please don't shout out answers into your computer and annoy your family. Um, this class is about how to break down big problems and an introduction to programming. And a lot of people, when they get midway through the course, they say, "Well, I've never programmed before, so it's way too hard." And I always look a little confused when people say that, because I'm hoping I'm not assuming anything about programming skill from beforehand. People that have programmed before have learned to use that particular muscle before, but we should be making no assumptions about your programming ability before this. However, I am not a workaholic, not a jerk. What's the word I'm looking for? I I have high expectations for myself and for others. I figure if I can do it, almost anyone can do it. And so Northeastern may have spoiled me a little bit. The students that are going there, you may not have heard of the school, but it's a very good university in the end for in terms of the quality of the students, because they have a co-op program like Waterloo. The students put all the faculty members to shame. The students were far smarter than the faculty member. We had years of experience on them. So I had to keep on trying harder and harder and harder assignments. And now I'm scaling back to, you guys are like me, mere mortals like me. And so I will be trying to make sure that the assignments are of reasonable difficulty. If they're too hard, please let me know. Uh, but they have to push you. They have to make sure that you are working and practicing, because you cannot cram for this course. You cannot memorize for this course. It will make no difference. I'm going to go on that riff again soon enough. The workload of the course is all about getting you to do the practice so that you can be good enough at it. And that requires doing repetition, like practicing a piano or whatever the case is. Um, what other people have also heard, I had one of my students point out that you hate headphones in class, and yes, that's actually a big pet peeve of mine. I hate talking in class, but we don't have to worry about that here. I will say there's lots of videos why you should learn how to program. This is why most schools don't why most schools don't teach. It's learning to code, and it's a video from a whole bunch of different celebrities. Uh, some are nerdy, some are not nerdy, but still at the same time, interesting video. But that's not the video I wanted to bring up. You could definitely watch it on your own. I liked it. Here's the one I wanted to bring up on my own. This, as you might imagine, based on the suit, is a very old TV show. This is a TV show called Connections with James Burke. It is from 1979 or so. So, even old by my standards. I was 3 years old at the time this show was taped. So, old. But it's a really interesting. I found it an interesting episode because it is him taking a new technological device like plastic at the time, like the nuclear bomb, like computers, taking a new technology from the past 50 years at the time, and going back in history to see how technological changes from the very earliest times that they can figure it out up to the invention of that device idea, whatever, what have you, comes about. So you start talking about money, then you go to windmills, then you and mills in general. Then you go to the cotton gin, which eventually gets to the U.S. Census, which eventually gets to the computer, for example. I found it a fascinating program. If you have a chance to watch it, I strongly recommend it. Very entertaining. But the last episode where I got the screenshot from is what's interesting. In 1979, James Burke is going over these massive technological changes. And in the end, he says, I want to go over, out of all these technological changes, I want to go over the one that I think is going to be the most impactful. And it's not the nuclear bomb, it's not credit cards and plastics. It's the personal, oh, it's the computer. He didn't say the personal computer because all of your information is going to be on these machines. And if you want to change the world, is the quote from the show is, if you want to change the world, get a PhD in computer science. Let me firmly state, do not get a PhD in computer science. It is not worth it unless you want to teach or do research. What he did not know, and what he could not know, is that instead of these gigantic machines in the background that you see, where you had data centralized in one particular place, that at the same time people were building computers in their garages, that the personal computer allowed anybody anywhere to get information to any information in the world at any time within about 10-year period, 15-year period. That you would never have a question that with an answer that you could not answer. That is a weird, weird phenomenon to have. The fact of the matter is, anybody can learn a program. Anyone can learn this. And when you learn it, you have the chance to shape the world. You have the chance to make a huge impact, because that is ultimately what drives so much of the world today is computers, either putting them together or programming them. But being illiterate to programming is a massive disadvantage to you. So, why should I listen? I guess I like posing hypotheticals. First of all, you shouldn't just listen. Really, I normally would expect participation in the class, but you have to actively think. And the exams are based on the lectures, but really, there's actually a bunch of steps in between that. You can't read a textbook and just magically get it. It's not psych. I have a psych degree. It's not psych. I was terrible at psych, by the way. Uh, it's actually, you have to listen, you have to process, you have to apply, and then the reflection, ties it all up again afterwards. And that is how you actually sort of internalize this information. You need multiple exposures to any given topic, and really you cannot do 3 and 4, apply and reflect, without 1 and 2. So if you're here, if you're listening, why are you wasting your time if you're doing something else? If you're checking your email right now, turn it off. And I know it's easier said than done. I had, I'm getting ahead of myself here, but I had this exact story. I had this exact problem. I was about to teach an online class at Northeastern. I'm watching the videos so I can teach a class to about 75 to 100 students. I'm watching the videos to learn the material myself because I did not know it in advance, or also to go over things. And even I was like, "Ooh, check my email now." Right? It is so easy. You have to turn off your cell phone, turn off the rest of the world, dedicate some time to just the class. I will make sure it goes hopefully as painlessly as possible, and hopefully it'll be the most efficient way for you to digest the material. I do not want to waste your time in any way, shape, or form other than this rambling right now. But if you try and multitask, if you try and do something else at the same time, or if you try and do it at the end of term, you will fail miserably. And this is from experience. This is from God knows countless students that have come through my classes that have tried that and that have failed miserably each and every time. So if you don't know why you're learning something, ask, because it should be directly applicable at all times. And when you listen and you process and then you use it, you'll be able to internalize it for yourself. And that's the only way you pass that exam. And ultimately, you're going to be doing other classes that use that skill set. So if you try and skimp on it now, you're sort of screwed over for 2400, then you're screwed over for your data structures class with Way. It's just this cascading problem that you're going to have. So you might as well put in the time now. And that does not involve memorizing. Memorization is useless here. It involves just sitting down and coding, or sitting down and thinking through problems. All right. So our learning objectives here. We want proper. Ideally, you would love to have proper documentation on all software projects. We want you to be able to describe a computer system and how objects or programs work. We want to teach you the basics of the C programming language, not C++, despite the fact the word C++ ends up popping around everywhere. The textbook says C++. The line in the sand that I'm taking here is, we're going to teach C now, and we're going to teach C++ later. They are very, very, very similar languages. C++ is essentially like the I don't know, enhanced version of C. Everything you can do in C, you can do in C++, and then some. But why throw in all the extra cruft now? I want to get the basics down in C, and then we'll move on to C++. We'll also be looking at binary 2's complement and numbers, how they're stored in the computer. We'll get to that very, very shortly. But the biggest thing out of all of this is I want you to think how you think about problems. Not just simple things like this, but how you reason about coding, how you reason about how you test things, how you reason about the world, how you reason about how a program runs. Because ultimately, that's applicable everywhere. So, this course may be hard, even if it's not your own focus, it will be important. I'm not assuming prior knowledge, but I can screw up, and I can just assume that you know what binary is, for example. I shouldn't, right? I need to make sure if I don't explain something well enough in a video, ask me. That's why we have the synchronous times or piano post, whatever the case is. If you're doing the work and you're asking a question, I can't say boo about that. I can't say anything negative about what you're doing. If there's no stupid questions in that context. There could be stupid questions if you don't watch any videos, don't read the syllabus, don't do anything at all, and then just before the exam say, what's the course about? Yeah, that's a stupid question. But for the vast, vast, vast majority of it, unless you're saying something, asking a question that's either racist, sexist, or you showed that you did not do any work in the course whatsoever, I will almost guarantee you I've said something stupider in class where they'd be like, what's 2 plus 2? And I go, 5. And just, yeah, I will not, you know, thumb my nose at you, or even if I do, you should get me fired, right? You are not expected to have prior knowledge. You're expected to do work, but you're not expected to have prior knowledge. Um, and so sometimes we forget. And unfortunately, there's actually a lot of evidence showing that a lot of times people blame themselves. Computer science is actually famous for being sort of there's a lack of diversity in computer science, or that has long since been the tradition. That's computer science in general, not necessarily IT, but programming in general has a lack of diversity. And when they actually do a lot of these studies, a lot of times people that are not, you know, not straight white men. There's a fairly large size gay community in the computer science world, which that there's some good representation there. But um, it's because there's this lack of diversity. If you're a woman in computer science, let's say, or you're transgender in computer science, or whatever the case is, uh, if you are in computer science and you see other people and they seem to get it and you don't get it, there's been evidence that people seem to think, I don't get it. It's my fault for not getting it. Versus if everyone around you that looks like you, acts like you, is it sort of your peers in how you view the world, all say, I don't get it, then you go, then the teacher's an idiot. So what you end up getting is large cohorts of people that all share demographic information with each other end up from the research end up going, well, that's a crappy instructor, and they rightfully blame the instructor. Versus if you feel like you're separate from the rest of the group, you're more likely to blame yourself. The only thing you can say about computer science or programming is real programmers program, the rest is opinion. It's not, oh, real programmers stay up till 3 in the morning and only drink Coke or whatever the case is. Real programmers play D&D. No, no. It's any great programmers can come from anywhere, and I've seen it. But the real kicker is the only this is very similar to if anyone's seen Ratatouille. Anyone can cook. It's not anyone has a gift of cooking. It is a great chef can come from anywhere. Anyone can be a great computer scientist or a great programmer can come from anywhere, even if you haven't done it before. I didn't do it until I did my computer science degree. I picked it up and found, oh my god, I have a skill at something for once in my life. That's amazing, right? Was never a computer. I was supposed to be a doctor. Uh, Programming in general, you don't know if you have a skill at it until you try. Some people will not be great at it, but you'll be passable. Great, right? But if you don't do the work, if you're not doing the assignments, if you're just ignoring this, if you try and cram at the end of term, no, you don't belong here. Get out. Sorry, that's a blunt way of looking at it. But Fact of the matter is, you can't cram for this. You have to do the work, and then it shows. And I don't know how many times I've said that to people, and they don't believe me, and then they blame me later, and they're like, but you didn't do any of this other stuff. I'll be monitoring how many times the YouTube videos get viewed. I did it last year with my 2400 class. And the videos I was posting at the end of term, they had like 13 views, 24 views. My 1400 class did amazingly well the same term, but my 2400 class, you know, 24 views. In a class of 100 people, 24 views. Not if you watch the video twice, it got 2 views. So less than half the class was watching anything at all up to the day of the exam. And a lot of them got crushed. And I recorded all the evidence showing that they did not do any of the work. You have to do the work. If you do the work, I will gladly jump on my sword if I screw up anything, or if I confuse you at all, or something's too hard. But if I have evidence that people are not doing work, and then you saying I'm too harsh, no, get out. This is university. You have to do the work. So you belong here, unless you don't. If you're going to try to get a coast by, it's an easy course. No, it ain't easy. And real programs can come from anywhere. Uh, Bonus little feature, I have a massive case of this, but imposter syndrome is alive and well, especially if you don't see people that look like you around you. Imposter syndrome is the feeling that somehow you don't belong there, that you're an imposter, and they're going to find you out at any moment in time. Um, it turns out it is very common amongst computer programmers in general. Um, it is something to look out for, that when you start thinking that you don't belong, you do. If you're doing the work and you got an A in this course, let's say, you deserved it. Just keep up the hard work. All right. So this course is not hard or easy. It's really ridiculously hard if you're trying to cram for it. It's actually not hard at all if you're putting in the work. It might seem hard from time to time, but we'll try and make it as easy as possible. And if you have a gift for it, it should be painfully easy, to the point that it's kind of boring. Okay, but it requires practice. It requires doing the labs. The labs are asynchronous. I'm going to post them out for you guys. You can look at them, or not look at them, you can do them, and the labs are there to help you do the assignments. That's what the labs are for. So we'll actually be more than happy to give out solutions to the labs, and the labs directly affect the assignment. I won't give the answers to the assignments in advance, but I can give answers to the labs. It's our little loophole. Um, and we'll have one synchronous and recorded class time, so you can ask your questions. We can discuss things. I can go over something again. You can think of it like a tutorial session. Most of the main content will be in videos, and then more of a free-flowing improvised lesson later on. So normally, right about now, I'm going to actually put a poll over a poll. I haven't done this yet. This It's actually June right now when I'm recording this. um, what we're going to be doing is I'm going to be inserting in polls throughout these lectures. Fairly simple questions. I have to leave them up for the entire week because I have no idea when you're going to be watching the video. Heck, I might have to leave them up even a bit longer than that. I'm not willing to leave them up all year, because what I want to do is get you onto a regular habit of watching videos, doing the work every single week. You can't cram it. So I need to make sure that things get spread out, and therefore I'll be putting polls into the video, so when you watch a lecture and I ask you to do a poll, go and do the poll. The the questions for poll over quizzes are not to stump you, they're not to trick you. I in fact would love it if people got them wrong from time to time. Not because I want you to get them wrong, but it shows when you don't understand something. So cheating on it is really counterproductive in my books, because it's going to make me think, oh yeah, they get binary, that's fine, move on. If everyone screws it up, that's a different story. So that is it. Also provide these kinds of quizzes and questions provide you the opportunity to get to a point and figure out, do I actually know what the hell he's talking about? Oh no, I don't. Oh, I'm in trouble. I did that with my math course as well. When I was taking math as an undergrad, like calculus, he'd say, "Oh yeah, here's a quiz," and I'd be like, "What is he talking about? I have no idea what L'Hopital's rule is. He's speaking gibberish." Yeah, you need the check-in to see if you're lost on a particular topic. So, by the way, in case you're wondering if this is important, this is for IMD, Interactive Media and Design, but your course requirements end up looking very, very similar to that. It is a cascading effect. I go from BIT 1400 to 2400. You may have a databases course in there, and then afterwards you go shuffling off to, I think it is, oh, data structures. Um, you go off to data structures and you'll be learning stacks and queues and all sorts of things, and then you go to maybe go off to 3D graphics, and then you may go off to this and that. You'll end up finding that BIT 1400 gets used more in the last 3 to 4 years, your third and fourth year of your degree, more than the vast majority of the stuff you do in the first 2 years. It's foundational to everything else. You're not going to use your calculus for the damn. Calculus might be there for some. I think you have to use calculus. It might be there for you, but I barely use calculus, and I found out I use it every day. But it's one of those things that I sort of internalized it. I didn't actually. I can't spit out an integral at any given time, right? I use computer science every day. Everyone that I know that's done anything involving technology is using some bit of programming every single day. If you don't believe me, you could talk to a graduate. I'm sure they'll be more than happy to point out how often they have to do some kind of script or something along those lines. Okay, so let me be a jerk for a second. This is not as directly applicable as it used to be. Normally, for my class, I'd say, oh my god, if you're going to put headphones on, get the hell out, right? There's no point being there. If you're going to have a side conversation, you're just annoying everyone around you, get the hell out, right? Text message each other, that would be fine, right? But you're supposed to be focusing on the class. The headphones really, really, really agitate me. Don't do other classes. This is just general advice for later on. So when I get you in 2400, provided we have a vaccine, if you do other classes in my class, you're going to get a very dirty look from me. If you wear headphones, I'm going to kick you out. Don't fall asleep in your class unless it's absolutely necessary. I have some students that just sort of accidentally fall asleep. Fine. But if you like assume the position, yeah, that's bad. But all those are for face to face. Here's the problem we have right now. That, or at least that's my problem. I'm really easily distracted, and I'm assuming many of you might be as well. It is ridiculously easy to go, yeah, I'll just check my email now at the same time. I will try and make it as efficient as possible, but you have to be here listening. Otherwise, you'll have to listen to it 3 times. No one wants to hear my voice 3 times. I don't want to hear it 1 time. So try your best, try and focus, and be there like you would be in a real class, just with a video instead. Don't try and multitask. Nobody can. I've lots of research that people cannot multitask. There is a slew of research. Don't try. Okay. So what are we talking about? I'm going to just briefly go over what is a computer, then we'll have a little intermission, and then we'll start a new video. So what is a computer? Yeah. You said you were going to waste my time. Well, I like to point out some little things about it, the definition. It's defined as an electronic device that stores and processes data according to instructions given to it by a variable program. And that one's the big one. Okay, let's see. The variable program. I don't care that it's electronic. I don't care that it stores information. The reason that computers are such a revolution is that the program can change. Decisions can be made, and variable inputs give to variable outputs. It is the revolution. It is the thing that changes everything. It's not a calculator. It can be expanded and mutate over time. And as a result, so we store information, the program can change, it's electronic, and those combination of things make it so extremely difficult to do, to program. There's a depth of knowledge you need to have and a breadth of knowledge you need to have. But it's not only hard to do, but it also means it's a little bit quirky. Okay, computers are everywhere, as you might know. Well, yeah, okay. Old picture, an iPad, an iPod, an iPad, and a laptop, fine. Uh, I love the fact that most of your toasters probably have a Linux build in them. If there's any chip at all in it, they probably have a very lightweight Linux build in there. It's easier than actually making a dedicated chip. Just throwing a Linux board in there. Your printers, any of these chip machines, electronics, clothing, it's everywhere. And they're all following the same general principle. So if you understand those, you understand how the world works. It is a massive advantage compared to everything else. Uh, Computers are universal machines. Okay, they execute the program that you feed them. Great. Only limits to imagination. There is actual limits to computers. Before you even have a computer, they found out what the limitations are. For example, you cannot prove that any random program will ever terminate, for example. But for the most part, we have not really hit the many of the upper limits to what you can do with a computer yet. And that is amazing given the amount of time we've been pushing the envelope. The envelope. The good news, computer does exactly what you say, and it does it fast. The bad news is the computer does exactly what you say, and it does it really fast. If you make some ridiculous decision, like I'm going to delete a bunch of stuff, and it's the wrong thing that you're deleting, you will look like an ass faster than you can possibly imagine. It's one thing to be a little bit embarrassed, like, oh, oops, I spilled my coffee. If you wipe out the database, yeah, you're fired, right? You can do immense amounts of harm if you don't know what you're doing. It's fast, it's efficient, and that's the problem as well. It's good and bad. Uh, Writing software is extraordinarily tough because you cannot prove when it's going to stop. If a program or a function is ever going to stop, yes, you cannot prove it at all. Uh, Programs randomly crash. You get weird side effects. Programs may not work as you expect. You cannot prove that they're going to work the way you want them to work, or in the limited cases you can. It's extraordinarily difficult. I've taught classes in that. Uh, and when they don't work, people die. And this is not purely hyperbole. Theric 25 killed, I think it was over 500 people in general. It was a radiation scanning slash dosing machine. So it's this machine that you go to when you go to you go to a hospital. They can scan your body like an X-ray for your body. Okay. Or if you have cancer, the same machine could be used to treat a tumor to give you radiation dosage. You use radiation in both cases. Fine. Except there was a bug in the machine. It was written in France, it was written in French, sold into the American market, all the documentation's in French. The interface is terrible, and they have a massive bug due to that as a rarely bug that would max out the amount of radiation you gave somebody on a normal scan on random weird occurrences. So when you went to go to your weekly checkup, this thing would give you a lethal dose of radiation. People were losing their jaw and they're losing parts of their body from the radiation burns and stuff. They would get radiation burns on themselves due to the Theric 25. The Ariane 5 rocket, for example, 1996, cost $10 billion, lost because of simple programming errors. They're everywhere. I love the fact that somebody broke into a casino using they hacked the Wi-Fi by putting, I think they put the computer in the fish tank at a casino and then use that to hack into the Wi-Fi system and then use that to break into the casino itself, right? The people were breaking into Target by sitting outside in their car and hacking the Wi-Fi, and they were able to go in and steal credit cards at Target in the U.S. That was like 3 years ago. It comes up. It's extremely hard to make it bulletproof. The systems that are robust, that you're going to make mistakes. That's just own up for it. They're going to happen. You're responsible for the correct functioning, and ideally, we're not teaching you to program. Any idiot can program. There's a lot of really bad programmers out there. We're teaching you hopefully to be good programmers, and that is not, oh, is your grammar right when you're doing your documentation. No, it is. There is an art form to doing this, and if you want to be considered with any level of respect, every programmer I know follows that particular art form. So we'll be talking about that in a second. But here's, by the way, is the Therac 25. And when it would give a lethal dosage, it would give you a pop-up warning that you could just say click, 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 and click past it, and then it would give the lethal dosage. So there was human factors. It's the giving tree of tragedy, essentially. All right, the Therac 25 has a user interface problem. It has a software development problem. It has a documentation problem. It has like a whole lot of lack of rules and regulations around it. It's just terrible. Um, it's difficult to get right. Trial and error is even less efficient than actually doing it right the first time. Uh, And my life lesson that I keep on finding out the hard way. I did it as an undergrad. I got a little bored and I programmed something and I'd say, well, let me try this crazy way of doing, my assignment. And I get all cutesy and then it bite me in the ass later, especially when it comes to real software in industry. Don't get cute. The code should be as simple as possible and no simpler. Your job is to be as lazy as possible. You want to be efficiently lazy. That's the key the mantra that I loved following. So, laziness, no, bad. If you can be so lazy that you never have to relook at your software again, great. If you can be so lazy that 6 months down the road, when you have to look at your software again, and you can read your documentation and you know exactly what you did, and don't have to reverse engineer everything, you save yourself hours of time, great. If you could be so lazy that you could write what you want to write and everyone reads it and goes, I know what that person is doing, great. Efficiently lazy, right? You want it so that you never have to see that code again if you can avoid it. Uh, you'll be designing your own applications. It's a lot of fun once you actually get your feet wet with this. You get to be really creative and imaginative. People don't believe me, but it really is a creative art form. Uh, it really does save lives, and it really is a great feeling when this runs. It is amazing. I I don't think some of you might learn to appreciate this later on, where uh, when you're programming something, you're cursing at this thing, and everybody does this. You curse and you swear you're never going to program again. Oh my God, this is a hell on earth. Why would anyone ever do this thing? This can't compile, whatever the case. And you scream and you want to throw something, and sometimes you do throw things, and then finally your program works, and it's like I'm not a drug user at all, but I'm sure it's like a shot of heroin for if you're a heroin addict. It is this, oh yeah, you want another hit of this thing. Like, it is the greatest feeling in the world. Actually, it's probably like going on stage and being an actor. You go through all of this hell when you suddenly get on stage. It's the greatest feeling in the world, and you're willing to go through all that hell again afterwards, right? When your program runs, it is a wonderful feeling, and you're really proud of yourself. So, if you get pessimistic at all, just letting you know, if you get through that, it is a wonderful, wonderful hit of endorphins. So, and my big thing for you guys, the reason why we're making sure you know how to program, I want you to be lazy in your job. So rather than you manually going and renaming things, or you manually doing this, or you manually doing that, the efficiently lazy approach is, can I get a script to do that for me so I only have to do it once and it works? That's what you want. You want to minimize the amount of work you have to do and look like a superstar, right? That's what we're trying to teach you. And that involves your code actually working, easily documentable, other people can understand it, and it's you only do it for when it's going to make you more efficient, but you want to be efficiently lazy. So, with that being said, we're going to take a little mini intermission, and then when we come back, oh, whenever you come back, we'll go over the syllabus and go over it. Hopefully, it's a bit dry, but so is that, and trying to make sure that it's very clear what the expectations for this class are. All right, I'll see you guys in hopefully in a second. Thanks.